Yes, I have made this video before. This video is a complete beginner's guide to solving the 3x3. I made this video twice, but let's just hope, fingers crossed, that the quality and editing on this one hopefully surpasses the previous two iterations. So yeah, let's get into solving our first Rubik's Cube by scrambling it up. Before we start turning here, there are a few basic things that we must cover. The Rubik's Cube is solved piece by piece, not side by side. There are three types of pieces, and we will only be moving two types of pieces around. Let's introduce the first type of piece, which is a centerpiece. The centerpiece, there are 6 of them, and they dictate what color goes on each side. So when the cube is finished, the side will be red entirely. And no matter how we turn the cube, the centers never move. Onto our second type of piece, which is an edge piece. There are 12 of these around the cube. Edge pieces contain 2 colors that are attached to each other like that. And lastly, there are 8 corner pieces. That's our third type of piece. And each corner piece will have 3 colors attached to them. So essentially, the goal of solving a Rubik's Cube is just to put 20 pieces back into their original locations. And let's see how to do that. Okay, with the basics out of the way, let's get started. Our first step is to build something called a daisy, where we put the 4 white edge pieces. Remember, edge pieces have 2 colors on them each. We are going to put these 4 white edges around the yellow center like this. That is our end goal, and let's get into the specific cases that you might run into. Most white edges can be intuitively solved in this step. For example, if I were to put the white blue piece up to the yellow center, I would simply turn the left side up. And similarly with the green, and then that sets up red. However, I do want to show you guys one case that is quite difficult. So say we have to insert this orange white edge, which is a flipped edge. Notice how if we turn the edge up to the yellow center, the piece is flipped. So in this case, we can first attach this white edge to the side and then replace the empty flower petal on top, which is like this. And we can replace it, giving us the daisy. For the next step, we want to align the side colors of the flower petals. So for example, we know that this red-white edge is aligned correctly with its center. So once you get a case like this, we can simply pretend that this bar is the hands of a clock, and right now it's pointing at 12 o'clock. We want to make it point at 6 o'clock by turning the face twice. And next, let's do orange. So since orange is aligned with green right now, let's fix that and align orange with orange. Pretend that this is the hands of a clock and turn it from 12 o'clock twice down to 6 o'clock. And do the same for the other 2 edges. And we have solved our white cross, which is our first step. Once you solve the cross, put the white cross on the bottom. This is your top layer. So next we are going to search for a corner. Remember, corners have 3 colors. We are going to search for a corner containing white in the top layer. And right away, I see this 4th of July corner with red, white, and blue. So this corner, first we have to determine where that corner fits. So since the 3 colors are white, red, and blue, this corner must fit in between the white, red, and blue centers correspondingly. So this corner must belong in this location. And once you figure out where the corner belongs, move the top layer so that corner is directly on top of where it should go. And once that happens, make sure the corner is on your right hand side. And this is when you know you can start doing the 4-move sequence, which I will show you. So 4-move sequence is right side up, over, right side down, reverse over. And you're going to keep repeating that until this corner is solved. Right side up, over, right side down, reverse over. And you'll notice that this corner has gone in. And then one special case that I want to mention is that if you run out of the white corners on top, that means that one of the white corners is stuck in the bottom incorrectly. So when something like this happens, keep the incorrect stuck corner on your right hand side and perform the 4-move sequence to take it out to the top layer. Right side up, over, right side down, reverse over. And you can proceed with business as usual. After inserting all of the white corners, your first layer should be complete. And we move on to our second layer, which involves solving these 4 edges in the middle. Our first step is to find an edge in the top layer that does not have yellow. In our case, let's do red-blue. Second step is to align the side color. The side color of the red-blue edge is red, so we align red with the red center. And from this position, we ask ourselves whether the edge goes to the left-hand side or the right-hand side. And a quick way to know is that the top color is blue, and since blue is to the left of red, that means this edge piece will be going to our left-hand side. After determining which side the edge goes to, the first move in this algorithm is always turn the top far away from where the edge should go. So in our case, the edge should be going left, so let's turn it towards the right side. And the next 4 moves involve the hand that the edge is going to. So remember the 4 move sequence that we did with our right hand, the first layer, we are going to mirror that since the edge is going into our left hand side. So we'll do the same exact 4 move sequence, but with our left, starting with left side up, reverse over, left side down, over. And next, we have to spin or reposition the entire cube towards the side that the edge is going to, which in our case is the left-hand side. So we rotate the entire cube. And lastly, we always finish the 4 move sequence with our opposite hand. So since we started with our left hand, let's finish the 4 move sequence with our right hand, which is just a normal 4 move sequence. Right side up, over, right side down, reverse over. And that inserts the edge. Let's do one more example, the orange-blue edge. So first, we have to align the side color, which is orange, align orange with orange. And now we determine whether the edge goes to the left-hand side or the right-hand side. And in this case, it's actually the right-hand side because blue, the top color, is to the right of orange. So we know that this edge must go down to the right-hand side. And the first move in the algorithm is to turn the edge far away from where it should go by moving the top layer like that. And then we perform the 4 move sequence with the hand that it goes to, which is again our right hand. Right side up, over, right side down, reverse over. And we reposition the entire cube towards the side that the edge is traveling to, which is the right side, like this. And lastly, we always finish the 4 move sequence with the opposite hand. And in this case, we need to finish with our left hand. Left side up, reverse over, left side down, over. We keep repeating the same big process over and over until all 4 edges are complete in the second layer. However, let's look at an exception case. In our special case, we ran out of edges to solve in the top layer. However, our second layer is still incomplete with 1 incorrectly flipped edge. To rescue any incorrectly stuck edge in the second layer, we simply insert another random edge in its place. So let's insert the blue-yellow edge into the right. First move is always move the top layer far away from where it should go, so let's move that to the left, and then perform the 4 move sequence with the hand that the piece should go to, which is our right. And then we rotate towards the side that the edge should go to, so towards the right-hand side, and finish the 4 move sequence with our opposite hand. And that takes out the red-green edge, and we can just do business as usual. The next step after the second layer is solving the yellow cross, as we have here. And here are 3 possible cases that you can run into: a dot case, a boot case, and a line case. There's only 1 algorithm needed. If you have a dot case, it does not matter which orientation you hold the cube, because the dot is symmetrical on all sides, and you simply perform this algorithm. Turn the face of the cube once clockwise, perform the 4 move sequence with your right hand, right side up, over, right side down, reverse over, and you're going to reverse your initial face move to fix the white layer, just like that. And there you will have a boot case. And when you have a boot case, ignoring the corners, of course. If you have a boot case, make sure that the boot is standing upright and facing out towards the left. And you do the same algorithm. Turn the face of the cube once clockwise, 4 move sequence with your right hand, and then reverse the initial face move. That guarantees you a line. If you have a line, you must hold the line horizontal and not vertical. And you perform the same algorithm for a cross. Face, 4 moves, reverse face. Now we must align all 4 side colors of the yellow cross. Let's start by moving the top layer so that at least 2 of the side colors actually align. So move and let's check. So in our case, orange is aligned, but nothing else. So let's move it again, and we can see that blue is aligned and red is aligned, meaning that we have to swap 2 adjacent edges, green and orange. So in this swap, face the edge that is traveling to the left-hand side. So green is swapping to the left with orange, so we face the green-yellow edge. And the algorithm to swap these two goes like this. You're going to do the first 3 moves of the 4-move sequence, right side up, over, right side down. Instead of the reverse over, like usual, you're going to add 1 more over. And from here, right side up, over, over, right side down, over. And that swaps the adjacent edges. Another possibility that you can run into is aligning 2 opposite side colors like this. And in this case, simply do a reverse over, and you have to do the adjacent swap twice. So in our case, we have to swap both orange and blue and red and green with the exact same algorithm. For our second to last step, we have something called the OK corner step. So an OK corner is either a solved corner or a corner where the 3 colors on the corner is correctly positioned in between the corresponding 3 center colors. So for example, this is a solved corner, but this is also an OK corner because orange, blue, yellow is correctly positioned in between orange, blue, and yellow. So back to our main cube, we realize that none of these are OK corners because orange does not belong next to red, and same problem here, and red does not belong next to orange. So, and none of these corners are solved. So none of these corners are OK corners. That means we just get to do this algorithm from any position. So the algorithm goes over, right side up, reverse over, left side up, over, right side down, reverse over, left side down. And after performing the algorithm once, we are guaranteed at least 1 OK corner. And we have it here. Orange, green, yellow is positioned in between orange, green, and yellow. So once you find an OK corner, keep it in the front right position and repeat the algorithm. Over, right side up, reverse over, left side up, over, right side down, reverse over, left side down. And you may need to repeat this 1 more time, but in our case, all of the corners are now okayed. For the last step, we turn our cube upside down. The bottom right-hand corner is the solving corner, and we want something unsolved there. And since all of our corners are unsolved, this isn't a problem. And we simply repeat the 4-move sequence to orient all of these corners correctly. So let's begin. Right side up, over, right side down, reverse over, right side up, over, right side down, reverse over. So that orients the corner correctly by pointing yellow towards the bottom. And from here, we just move the bottom layer so that something unsolved is in the bottom right solving corner, like this, and then we repeat the process. So again, yellow points towards the bottom, so then we know to move another unsolved corner into the solving slot. Again, yellow points towards bottom, switch the solving corner, and repeat the 4-move sequence until your cube is finished.